Hi, today we will be learning subnetting and type of network class. So, subnetwork or subnet is actually a logical subdivision of an IP address. You can see definition here. In subnet marks, every device has an IP address with two pieces. One is allocated for host address and another is for network address, and each IP address are either configured by DHCP server or manually configured, or you can say static IP address. And there is another definition that the subnet marks split the actual IP address into host and network address, thereby defining which part of the IP address belong to the device and which part belong to the network. So this is the subnet mark. It is in simple we can say subnetting is the practice of dividing a network into two or more networks. And here we'll be learning type of network class division. You can see there are class A, class B and class C network, and then bits range. Class A network range from 0 to 127. Class B range from 128 to 191, and Class C network range from 192 to 223. And you can see subnet marks for Class A is 255.0.0.0, and subnet marks for Class B is 255.255.0/0. For Class C, it's 255.255.255.0. Similarly, CIDR value for Class A is 8. If you ask why CIDR value of Class A is 8, it's because it allocates 8 bits for the network bits. That's why the CIDR value is 8. So CIDR value for Class B is 16 and Class C is 24. You can see network bits is 8 for Class A, 16 for Class B and 24 for C. Likewise, 24 bits for host bit in Class A and 16 host bit for Class B and 8 host bit for Class C. Similarly, you can see Class D bits range from 224 to 239 and Class E range from 240 to 255, but we are not discussing these two class. We'll be discussing only Class A, Class B and Class C network. So you can see further more information here. Class A have a CIDR value /8 because it have 8 network bits. You can count from here. You can see this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 4, and this is 2 to the power 5, 6 and 7. So all together there are 8 bits which are allocated for our network bits. That's why the CIDR value is also 8, and IP range from 1 to 126. You can see IP address like 10.0.0.0. It's a Class A IP. Or if you can see like 15.0.0.5, it's same, it's a Class A IP. So subnet marks for default subnet marks for Class A network is 255.0.0.0. So if you subnet marks is 255, then you can see the calculation over here. It's because we have calculated this all the value. 2 to the power 7 into 1 plus 2 to the power 6 into 1 plus 2 to the power. So in that way we get 255. That's why the subnet marks became 255.0.0.0. If you calculate this value, it will be 0 because you will multiply 2 to the power 7 into 0, it will be 0. 2 to the power 6 into 0, it will be 0. That's why the value will be 0, 0 and 0. So this is the class AIP. Next we'll be doing class B. So in class B network, you can see the CIDR value is 16 and IP address range from 127 to 191, and default subnet mask is 255.255.0.0. and here you can see 16 bits are reserved for network bits and remaining 16 bits are reserved for host bits, and if you calculate it, you will get 255.255.0.0, which is our default subnet mask. And next is class C IP address. For class C IP address, our CIDR value is 24 because network bits reserved for 24 bits. That's why CIDR value is 24. And then IP address range from 192 to 223, and default subnet marks by calculation you will get 255.255.255.0, which is our default subnet mask. And in class C, 24 bits are reserved for networking and 8 bits are reserved for our host bits. Okay, now let's do subnetting in class C IP address. So here we will be learning how to find the number of network, and then how to find a number of IP address, and how to find number of hosts in each network. So here I have take one example of class C network, which is 192.168.20.0/25. By default, CIDR value should be 24, but here you can see 25. So to make it 25, you have to borrow 1 bit from host to the network. So now if you can see here, if we borrow 1 host bit, then new subnet marks will be 255.255.255.128. You all have already know that default subnet marks should be 255.255.255.0, but you can see it's different here. It's because we borrow 1 bit from host to the network. So if we calculate that value, 2 to the power 7, because we have borrowed one bit, right? 1 bit, this one, we have to borrow this one, and the value for this one is 2 to the power 7. So if we calculate that, 2 to the power 7 into 1 equal to 128. That's why the value is 128 here. Now let's see how to find the number of network. The formula to find number of network is equal to 2 to the power n, where n indicate total number of bits borrowed from host. And we know we borrow only 1 host bit to the network. So the formula will be 2 to the power 1 equal to 2. So by calculation you'll get 2. So we can create only 2 networks. We can create only 2 networks with this CIDR value 25, with this IP address with CIDR value 25. So now how to find the number of IP address in each network? You already know we can create only 2 networks. So this is network 1 and this is network 2. So how many IP address we can create in one network? So how many IP address we can create over here? So to find out that, you need to use another formula, which is 2 to the power n, but here n indicate total number of remaining hosts. So you already send 1 bits to the network bit, so remaining bits will be only 7 bits. So 2 to the power 7 equal to 128. So on each network you can have 128 IP address. So in each network you can have 128 IP address and 128 in another network. So now how to find the number of hosts in each network? So everybody knows that first IP of each network is always allocated for network ID and then last IP address is allocated for broadcast ID, and remaining in between those, the remaining IP can be used for host ID. So those IP we can connect to the other devices. So let's calculate host IP. So to calculate host IP, you need to use formula 2 to the power n minus 2, where n indicate total number of remaining host bits, which is 2 to the power 7 minus 2 equal to 128. So from first network, we can assign 126 IP address to connect to the other devices. And from second network, we can connect 126. We can use 126 IP to connect to the other devices. Let's go to another slide. So from this picture, you can clearly see we have created two networks according to our formula. From here, we can create only two networks, which we have created two networks. And in each network, we can create 128 IP address. You can see I have created 128 IP address from 0 to 127. And similarly, in second network, I have created 128 IP address from 128 to 255. And here you can see how to find number of host bit, which is 126. So you can see from 192.168.20.1 to 126, these are our host ID. So now from overall information, I think you have learned what is network ID and what is broadcast ID. So the first IP address in each network is allocated for network ID, and last IP address is allocated for the broadcast ID, and remaining in between those network ID and broadcast ID are the host ID. So let's take another example of class C network, which is 192.168.20.0/26. By default, CIDR value for class C network is 24, but here in example we get 26. So to make it 26, we need to borrow 2 bits from our host to the network. So if we borrow 2 host bit, then the new subnet marks will be 255.255.255.192. So how we get 92, you can see here, because we borrowed 2 host bit to the network, that's why. And the value for this 2 is 2 to the power 7, and then this one is 2 to the power 6. How to find number of network is 2 to the power n, where n indicate total number of bits borrowed from host, which we have borrowed total 2. So 2 to the power 2 equal to 4. Now how to find number of IP address in each network, which is 2 to the power n. This time n indicate total number of remaining hosts, which is 6, because 2 already we sent to the network bits. And now according to calculation, 2 to the power 6 equal to 64. We can create total 64 IP address. Now let's go and find number of hosts. 2 to the power n minus 2, where n indicate total number of host bits, remaining host bit, which is 6, and now 2 to the power 6 minus 2 equal to 64. So we can create total number of 62 host IP. Let's go to another slide. Here you can see we have created total 4 networks, and in each network we have created 64 IP. Total number of IP you can see here, 64 IP. So you have to add 64 in each network. So 0 plus 64, you will get 64. So 64 plus 64, you will get 128. So now 128 plus, so in each network you need to add 64, 64, 64, you'll get 192. And last IP will be 64 minus 1, 63. 128 minus 1, 127. And 192 minus 1 will be 191. If you add 192 plus 64, it will be 256. So if you minus 256 minus 1, it will be 255. So first IP is always allocated for network ID, and then last IP is allocated for broadcast ID, and in between them you can get the host address that you can use to connect to the other devices. So that's it for today. In next video we'll be learning how to do subnetting in class A and class B network. So thanks for today.